So myself Rekha, Assistant Professor, Department of Mathematics. Today I am going to present the topic Resource Management Technique. The topic name is Linear Programming Problem. So normally linear programming problem is nothing but optimizing the allocation for a limited resource to meet an objective. So this is good example is main raw material, market demand, etc. Here the main objective of the linear programming is nothing but maximizing the profit or minimizing the total cost. Here we have to decide the decision variable for the solution. The variable should be on objective function and the constraints of first degree. So that is normally linear programming problem should be deals with the maximization or minimization, and it should have a set of constraints and a non-negative restriction. Let us consider a problem. It is an industry oriented problem, so you can take an industry engage with the two models. So for the two models we have to print, assemble, testing for etc. The model A got a profit of rupees 50, and whereas model B got a profit of rupees 80, and now total number of hours for assemble is 600, 100, and testing is 30. So in this problem we have to formulate the maximizing the profit. So first of all, in this problem we have to find a decision variable, that is how many decision variable. So how many rupees are there? There are 2 rupees for model A 50, model B 80. So if it is 2 rupees means you will have a 2 decision variable, and you can identify the problem is in maximizing the profit. So let us consider the maximizing Z as 50x1 plus 80x2, and then we have to choose the constraints. So how to choose the constraints? So for the assembly, what is the time taken? So it should be a see the tabular column. It should be, or assembly it should be 1.0, and for model A, and 1.5 for model B. Similarly for painting and testing, so on. So from that you can construct the constraints. So the time constraints for the assemble is 1.0x1, 1.5x2 less than or equal to 600, and 0.5x1 plus 0.2x2 for 100, and 0.0x1 plus 0.1x2 less than or equal to 30. So this is your constraint. Now we have to combine our objective functions, and you have to formulate the LPP. Already we have done the maximizing Z, no? So then you have to write the maximizing Z and the subject to the constraint, and at last you have to declare that it should be negative restriction. Why it is means, because always the company will produce a positive only, positive some values only. So it should be a greater than or equal to. So can refer this book also, that is Sundaresan, Ganapati and Subramani. Okay, thank you students.